Okay, so you have another equation up here, a systems of equations. As Mr. Craig just got done teaching you how to graph each of these, and then you just look where they intersect, and where they intersect is where that solution is as an ordered pair as an x comma y. If you guys go ahead and take a second, pause the video even now and try graphing both of these equations on the same graph. And I'll go ahead and assume that you did that already. Did you notice anything different? Well, let me graph them really quick. Let's make sure your graphs match mine. I'm going to take my first equation right here, which is 6x minus 2y equals 10. And I'm going to go ahead and solve for y to put that in the slope-intercept form. So let's go through that. The idea here is I want to get y alone, right? So I'm going to go ahead and I need to get rid of this negative 2, but I also need to get rid of this 6x. That 6x is what I'm going to get rid of first by subtracting it off of both sides. Get my lollipop here so I know what I'm doing. Let's see what we got here. 6x minus 6x is 0. Let's bring down everything that we got so far. Negative 2y equals a negative 6x, and that is a positive 10, so plus 10. And then let's get rid of that negative 2 now. Get rid of this negative 2, this coefficient, by dividing everything by negative 2. And now we are left with y equals negative 6 divided by negative 2 is 3x. And then 10 divided by a negative 2 is negative 5. So here we have a slope of 3 and a y-intercept of negative 5. So I'm just going to write that out really quick for my benefit here. Let's go graph this line. All right, so my y-intercept is at negative 5, so 1, 2, 3, 4, negative 5. My slope is 3, which is really 3 over 1, so rise 3, run 1, run 1, rise 3, run 1, rise 3, run 1, rise 3, run 1, rise 3, or you go the other way, run 1, rise 3, so on and so forth. So here we have a nice graph of the line. Let's get that line drawn in there. If I could draw a straight line. Awesome.
That's an awesome straight line, Mr. Nelson.
Oh, I thank you, Mr. Craig. So let's see here. Let me circle that one in red. So we just did this equation right here. Now, the other equation is already in slope-intercept form, but you may have noticed something. This is also y equals 3x minus 5. That's the same slope of 3, and the y-intercept is also a negative 5. And if I were to graph that, you end up with the same line. But I'm going to do that really quick. Negative 5 is your y-intercept, and then we're still running 1, rising 3, running 1, rising 3. We have all of these same spots, same points, and also the same line. And so this is really interesting because what Mr. Craig said earlier about solving for a solution is usually we look where they intersect. Well, where do these intersect? They intersect everywhere. They're touching everywhere. So the solutions to one line are the same solutions to the other line, and they all have the same solutions. And because they're touching at those solutions, all of those numbers are solutions. And so what we have here is when you're graphing the line, the same line twice basically, you have what we call as infinite solutions. I feel like that took an eternity to write.
And that's why we abbreviate.
Yep. So we have infinite solutions here because we have all points touching, right? It's where the lines intersect. If they intersect at one point, you're going to have one solution. But if they intersect at all points, then you're going to have all of those solutions. And because these lines keep on going off to infinity in both directions, we're going to have an infinite amount of solutions. Let's continue on. Go ahead and pause the video and try this one. All right, so got two equations again. One looks really easy to graph already. I'm going to go ahead and jump over to this one really quick, and I'm going to go ahead and solve this one. Solve for y, get it to slope-intercept form, and graph it. Let's go ahead and do that really quick. Get my lollipop here. Cool. I want to get y alone. Don't have a coefficient to get rid of, but I do have this constant. So we're going to add 2x to both sides. And that's going to leave me with, that's 0. Y equals, it's going to be a positive 2x, and that's a positive 8, so I'm going to write plus 8. And that's nice. It was nice and easy. So we have the slope of 2 and a y-intercept of 8. Let's do that. Y-intercept of 8 is right here. Our slope is a positive 2, so that's going to be a, remember it's over 1, so we have a rise 2 and a run 1. Run 1, rise 2. We're going to go the other way as well. I feel like this could also take an eternity, and this is where I get really chipmunk soundy and I go really fast. There we go. So there is our line right there, that equation.
Straight as a rainbow.
Yeah, definitely. So here we go. We've graphed this line, and that's the same as this one right here. Let's go graph the other one. This is y equals 2x minus 5, where the slope is 2, and the y-intercept is negative 5. And so the y-intercept, negative 5, 1, 2, 3, 4, negative 5. A slope of 2. Well, that was the same slope, which is going to be interesting, because that means run 1, rise 2, right? And we keep on doing that same pattern all the way through the graph so that we can make a nice straight line. And if the solutions are where the lines intersect, how many solutions does this have? Well, are they ever going to intersect? Because every time this goes and runs 1 and rises 2 down, or goes to the right 1 up 2, this line does the same thing, goes to the right 1 up 2. So these two lines will never intersect.
What do we call two lines that never intersect?
We call these lines parallel lines.
Oh.
However, this is not my solution, right? Parallel is not my solution. Remember, the solution is where they intersect, and if they don't intersect, well, then that must mean they have no solution. So parallel lines will never have a solution because they never touch.
So we don't write parallel though. We just
No.
write no solution.
Now, yes, here you go, right here. This is your answer right here. But there is no answer. That's the answer.
Awesome.
All right. Pause the video. Try this one out. Okay, here we go. Looks like, again, one of these is in slope-intercept form. That's already nice. Let's go ahead and solve this second one here. And let's solve for y to put it into slope-intercept form. I'm going to lollipop. I need to get this y alone, which means I need to just get rid of this.
Mr. Nelson, does it
constant
not
over.
matter which one we do first?
It does not matter which one we do first. I look at which ones need the work, I do the work, and then I'll graph both at the same time.
Cool.
Yeah. So let's get rid of this constant here. Let's see, add 2x to both sides. Negative 2x plus 2x is 0, and that just leaves me with y equals 2x, and that is a minus 4. So minus 4 here. There we go. So we've got 2x minus 4, and that means my slope is 2. My y-intercept is negative 4. Let's graph that. I'm going to graph this one in blue. I'll even circle here. Let's do this one in blue.
Again?
Blue! I like blue! For the colorblind people in the room. My slope is 2, so same thing as the last one. We're going to run 1, rise 2. Run 1, rise 2. So on, and so forth. Same direction, or same steps in a different direction. Okay, let's get that line going here. Wow, what happened there?
And this is why it's important to pay attention to detail.
Pay attention to the details. All right, let's see here. So we're going to do this one now. Do this one in red. That slope is 2, and the y-intercept is negative 1.
Begin.
Begin in there. So we're going to begin at negative 1, and my move or my slope is 2 as well. So run 1, rise 2, run 1, rise 2. You noticing anything here?
Hey.
Are we ever going to intersect that line?
No.
I don't think we are. I would
Well, if
continue
your
off.
line is crooked like that, maybe.
If the line's crooked enough, yeah. As you can tell, none of these points are going to actually intersect. No matter if we keep on going down into the negative direction or the positive direction, we end up with two lines that never intersect again. So this is also no solution.
Because the two lines are parallel.
Two lines are parallel, they're never going to touch. So you can't have a solution. All right, one more here. Go ahead and give that a try. Alright. Alright, I'll do this one in green, as long as the other one's in blue. This one right here we're going to do in green. Let's see here, I need to get the y alone, right? Again, volume pop. Gotta get rid of that coefficient. Gotta get rid of that constant. Get rid of the constant first. Minus 5x from both sides. That'll nice go away for us. Let's bring down everything else really quick. It's a negative 5x, and that is a positive 14, so plus 14. We need to get rid of the 7, so we're going to divide by 7 here to get rid of the coefficient. And that's going to leave me with y equals, remember to divide everything by 7. This is going to be a negative 5, 7 over 7x. And then 14 divided by 7 is
Dose.
dose, but positive dose, right? Positive 2. So that means that my slope is negative 5/7. And my y-intercept is 2, or my begin point is 2. All right, let's go ahead and graph that one over here in green. We got my begin at 2. 1, 2. My slope is a negative 5/5, so I'm going to goodness. Let's run. So this is my rise is -5, run is 7. So 1, 2, 3, 4, 5, 6, 7, and then down 5. 1, 2, 3, 4, 5. I do want that negative slope. So let's go this way. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Man, I have to draw a line through that.
Good luck. Remember, students, you can use a ruler or the side of your book or any straight edge that you have to create a nice line.
And that would be nice to do.
Don't be a Mr. Craig or Mr. Nelson.
Yeah, use a ruler. Use a straight edge somehow. All right, this one right here is already solved for in slope-intercept form. It says my slope is -5/7. That's how I'm going to move. Well, that looks interestingly familiar, doesn't it? And my y-intercept is also 2. That looks interestingly familiar. I wonder what's going to happen. Well, we go to the begin point here at 2. And then we graph it with -5/7 to move. So 1, 2, 3, 4, 5, 6, 7. Run of 7. Rise of -5. Uh-oh. Same thing this way. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Uh-oh. What's happening?
It's the same line.
It's the same line. That means these lines are touching everywhere, which means we have infinite solutions. Now, what you should do is go down to the problems below this video and do them. If you have problems with them, don't know what to do,
Come on Zoom.
you could go on Zoom the following Friday meeting. You could come meet us and ask us questions, or you can take a picture of your work and be like, I don't know what to do. Send it to your teacher, and we can help you out even more.
But don't send a picture of the problem without your work
We need
attached.
to see your work. So make sure you email us your work, not just the problem, but your work. What did you do so far, and then where are you stuck? That way we can help you. Anyway, good luck.